Okay, so this video is on integrations, specifically those integrations that we do by parts. So first of all, let's start with the theory. So this concerns integrals where I'm integrating a product of functions. Now, to be able to do this, I'm going to first of all define a new function, which I'm going to call an antiderivative. So capital G of x, such that if I were to differentiate g of x, I would end up with my lowercase g of x. Okay, so here I have my antiderivative. Now, the place where we've come across products of functions before, when we've been doing calculus, is obviously when we've done differentiation. So let us now look at differentiating the product of functions. So let us differentiate f of x and my antiderivative. Now, applying the product rule to this, I end up with f prime of x times capital G of x plus f of x g prime of x. Now, from my definition of my antiderivative, I know that I can express this as lowercase g of x, like so. My next step is to go through and to integrate these things with respect to x. And yes, we can integrate each of these as parts, and that's something that you will learn about when you study maths at university. So here we will have f of x antiderivative is equal to the integral of f prime of x g of x with respect to x plus the integral of f of x g of x dx, which is the thing that I'm interested in finding. So let's rearrange this to give me f of x g of x minus the integral of f prime of x g of x dx, which will be equal to the integral of f of x times g of x. Now, it may look complicated, but if we can remember where this antiderivative comes from, i.e. that we can generate it just by integrating our g of x function, things become very straightforward. So let's now move on to the notation that we will be using for the rest of the time. I'm going to call my f of x function u. And so over here I've got du by dx, and I'm too lazy to write anything else, so I'll just leave that as du. And here my f of x function again is u. Nice letter that comes after u is v. Here is v. And obviously to find my g of x, if I know what g is, I would need to differentiate my v function. And at this point we have our rule that we will use for integration by parts, and that is to say that u times v minus the integral of v du is equal to the integral of u dv. And here we have that rule spelled out for us very clearly. It's always in the formula booklet and should be something that you memorize. So let's get straight into questions. So here we go. Most importantly is what we're going to choose to take as our u function and our dv function. Now, at the start of this video you'll have seen that I called this the build it up, break it down method, because there's one function that we're going to build up, the integrating function, that's going to always be there, and one function that I'm going to break down that I'm hoping is going to disappear to make my integration easier. So the thing that I'm going to break down here will be my x value, and because I'm looking to break it down, that will become my u, leaving dv to be e to the x. If I differentiate this, this becomes 1. If I integrate this, v is e to the x. And at this point I'm ready to go straight in and use my formula, because I know that the integral of u dv is equal to, from my formula, u times v minus the integral of v du. And you see now how lovely this is, that we've eliminated that x, and I've only got one function in here in my integral now, which we can deal with very simply, and this becomes e to the x. And I must just add on my constant. Next example, so you can pause the video to have a go. Again, we want to think about which function do we want to build up, which one do we want to break down. Again, I'm going to break down my x, so u is equal to x, leaving dv to be equal to sine of x. So that means that du will be equal to 1, and v will be the integral of sine of x, and sine of x integrates to give me minus cosine of x. So this time I have to be careful with my signs. So the integral of x sine x dx is equal to u times v, which is minus x lots of cosine x, minus the integral of v du, which is minus cosine of x dx. Again, this is what I was saying about being careful with signs, so I'm going to rewrite this as minus x cosine of x plus the integral of cosine of x dx, which is minus x cosine of x plus cosine integrates to give me sine of x plus our constant of integration. Next example, again, perhaps you'd like to pause and have a go. Right, this time in a similar way I'm going to let my u function be the one that I'm going to break down, so u is going to be x squared and dv is going to be e to the minus x, which then means that du is going to be 2x and v will obviously be minus e to the minus x. Okay, straight into my integration, so I've now got the integral of x squared e to the minus x with respect to x is equal to u times v, which is minus x squared e to the minus x, minus the integral of v du, which is 2x times by minus e to the minus x. With respect to x, again, have to be careful with my signs here, so I'm going to deal with that first and say that that's minus x squared e to the minus x plus 2 lots of, bringing the 2 out the front of the integral, x e to the minus x dx. Oh dear, this is again something that we can't integrate. However, we can just apply our integration by parts again, and that is to say that this time u is going to be equal to x, and in this case dv is equal to e to the minus x, and run through the whole process for the second time. So now our integral becomes 2 lots of okay, and again I need to be careful with signs in here, and realistically I should drop in the rest of my working from my previous line, otherwise I might forget about it and give the incorrect answer. And on we go, which gives us minus x squared e to the minus x plus, multiply the 2 through the bracket, so this becomes minus 2x e to the minus x, and dealing with the negatives first, this becomes plus, multiply through by 2, integrate e to the minus x, that becomes minus e to the minus x, and my constant of integration. So I might want to go through and just have a final tidy up of signs, so this becomes minus 2, and the minus in here I can bring to the front to give me my final solution. So we often end up with questions where we have to do sort of a nested by parts method, so we do by parts once and then end up with another integral where we have to do by parts again. Now for a wonderful trick, and that wonderful trick is the integration of the logarithm of x. Not immediately obvious that this is a by parts question, until we realise that we can write this as 1 times by the logarithm of x. Now in this example we're going to take our u value to be logarithm of x, which is sensible because at the moment we don't know how to integrate logarithm of x, so I want to pick it as the function that I'm going to differentiate, because I know that's going to become 1 over x. My dv function is going to be 1, which I'm going to integrate to give me x, and at this point I'm ready to go because I know that the integral of logarithm of x dx can be written as u times v, which is x log x, minus the integral of v du, which is x times by 1 over x, and x times by 1 over x just gives me 1, so this becomes the integral of 1 dx, which of course is x plus just x plus our constant of integration. And there we have a wonderful trick for integrating the natural logarithm. Okay, time to get on with some practice. Thanks for watching, and please let me know if you have any questions.